Let's go. Okay, let's get going. Let me clear the decks. What we're going to go through today is 11.5, which is sort of the most important section. Well, actually, it's not. The inverses are important. The composites are important. This whole chapter is important, but the cornerstone of this chapter is 11.5. It combines a little bit of everything we've been working on this past 2 days. All right, let me grab my notes. Let's see, not there. All right, 11.5. Give me 1 second. Let me grab something. So you don't have to copy anything down that I'm going to write right now. I just want to explain something. Now, right now we have calculators, which is nice. But back in the day, someone had to hand create these log tables, which was sort of this lifetime process. So you would have some person that would go, let's see now, 2 cubed. That would do something like 2 cubed is equal to 8, which means log 2 of, let me make it, yeah, log 2 of 8 is equal to 3. And then you'd have someone that would do, let's do 4. That's a better example. So someone would have 4 squared is equal to 16. Again, don't copy this. So then you would know that log 4 of 16 is equal to 2. See, that's the exponent. And then you'd say, well, what else could I get out of this? You'd say, well, 4 to the half is equal to square root of 4 is equal to 2. So then you get log 4 of 16. Log 4 of 2 is equal to 1/2. And then if you wanted to, you could use the properties that we learned yesterday to come up with 2.5. So for example, now if I did, well, log 4 of 2 plus log 4 of 1/2 is equal to log 4 of let's see, that's equal to 2 times 1/2. And then you would see that, I'm sorry, log 4, 2 log 16. There we go. 2 times 16. And then you'd say, well, log 2 is 1/2, and log 16 is 2. I'm just taking these values. And this is equal to log 4 of 32. So then 2 and 1/2 is equal to log 4 of 32. So the first things you would do is you would find all the logs of things that you knew how to take exponents of. And then you'd use these log properties to try to get other ones that aren't so obvious. And then you play this game, you try to use algebra to fill out a table for logs, because back in the day, we didn't have a calculator.
Professor,
So, go ahead.
how did you get 1/2 out of log 4 2 times 2?
Oh, so over here, that is what the log is always equal to. It's equal to the exponent. Now, they have the same base. So this is always the parameter. So the resultant of the log is what the exponent will be. So you want to think of this as square root of 4 is equal to 2. 4 squared is equal to 16. So usually what happens is you think of all the different ways that you can do exponents. You figure out all those, and then you fill out that part of the chart. And then you use addition and subtraction to, so let's say I did on a different one. And if you came in late, don't copy what's on the board. So if I did something like this, log 4 of 2 minus log 4 of 16 is equal to log 4 of 2 divided by 16. So then I get, let's see, this would be a half minus 2 is equal to log 4 of 1/8. And then you get negative 1 and 1/2. Yeah. Is equal to log 4 of 1/8. So back in the day when you didn't have calculators, you wanted to look up some log, you had to go and find some chart where someone manually created all of this. And let me show you what these charts look like. Let me pop one up. Let's see. Long table. Logarithm. There we go. All right. So let me pop it up. Where am I? Okay. And look at this. Someone would go and find all the logs, and they would hand do it. And so I don't know. You would just pick one base, and that was your life. You spent your entire lifetime building the log for base 2 or building the log for base E. And it was miserable. I mean, it was done by hand, and all you did over and over and over was try to use arithmetic and basic exponents to figure out what this is. And what was sad is that if you made a mistake early on, that error propagated everywhere. So people would look at this and go, this is really good. There's only like 20% of this log chart that's wrong by 2 decimal places, right? So now that we can double check it, we could see where the error started, how it propagated through the table, and we could talk about, yeah, for the first 20 years was pretty good, but the last 30 years of his life, all he was doing is propagating errors. And that was someone's life. Okay. Now, at a certain point, so still before computers are created, at some point, you want to go like, can I just use one of these tables to, like, let's say I have log base 16, log base 9. And I go, I only have a chart for log 4, but I don't want to spend my life trying to figure out what log 9 is just for this one number. Can I use these old tables to give me my answer? And the answer is yeah. Yeah, you can't. So we have what's called the change of base formula. It's not as necessary now because we have calculators, we have computers that automatically compute log for any base. Well, let me just make sure I do this right. Yeah. I think the x goes on top, right? Yeah, the x goes on top. Now, this is a different base. So go ahead, copy that. There's a, I'll show you in a way that's easier to memorize. Okay. Now, different calculators have different buttons. Some will just have something that says log. And usually, this is log base 10. Okay. Some of them will just have ln. And some of them will have something that looks like log x y. Let me see how it is on my let me make sure x's and y's might be flipped. Let me see my calculator on my iPhone. No, it's not there. Well, usually it's like log xy. Okay. Now, in the book, they'll give you something like use change of base to find log 514 on your calculator. So these are the first questions. And it's just a question of, can you use your calculator to find the logs? Now, if you have this button, so usually you'll say log or with nothing here, or sometimes it'll have a 10 here. What you'll do is you'll say, well, log 514 is equal to log 14 divided by log 5. So it's always the parameter over the base. So you can use any log. So this is just saying, let's say your calculator doesn't have this. Then you can use just a regular log base 10 to figure out what that is. You don't need to buy a new calculator. And in the ancient days, you didn't have to buy a new book of logs. You could just use whatever table you had. If your calculator has this button, right, so this one is log base E.
Professor?
Go ahead.
Is there a difference between a non-cursive log and a cursive log?
Non-cursive. No, they're the same thing.
Okay.
It's just how it looks, yeah. So if you go log 514 is equal to ln 14 divided by ln 5. And then if you have this button, So the x always, x is the first number. Y is the second number. Now I can't remember if the calculators say like that have to say log y x or log xy. It doesn't matter. But just know that the x always comes first. So if you have something like think of it as x divide y. So if you were trying to do a division, you would say 10 divided by 2. That's what you would press. The x always comes first. So in the same way, if you have log xy, the base would come first, and then you hit the log button, and then you hit the second number. So any of you who have really nice calculators that have all these functions, you look at the x and y notation, you go, I don't understand what the xy notation is. It means that's the first number, then the button is the operator, and then the y is the second number. And then let me put this is section 11.5. I'll tell you what the name of the section is in a second. Let me take a picture of this, and then we'll get to the heart of it now. I'll explain what the name of the section is. Okay, so go ahead, copy that. And then the reason why we have this problem is that when you take chemistry, your teacher doesn't want to explain your calculator to you. They want you to sort of take a math class and just know how to use your own calculator. Okay, so that's the first bit that we have. I'm going to erase this now. Now, section 11.5 is solving log equations. Now, we've done that in the past. These are just a little more intense. They're not that bad. They look terrifying, but they're going to be okay. These are a little more intense because we're going to use the properties of logs, right? The thing that we did at the end yesterday. Okay. Okay. Now there's two. There are two main problems that I will especially push on. Okay. So let's look at something that looks like this. Solve log x plus log x minus 9 is equal to 1. I'm going to erase this side now. Okay. Now the problems that we work on today all have the same setup. So the first thing you want to do is combine the logs. Okay, that's always the first thing we do. So the first thing I'm going to do is I'm going to combine these two together. So remember that addition means multiplication. Subtraction means division. Okay. So what happens here is that we have log x times x minus 9.
Professor,
So yeah, go ahead.
why are you multiplying, not adding?
Oh, see, what I'm doing is, see, yesterday we had this thing where we said expand log A6 B7, and we said, oh, that's equal to log, that's equal to 6 log A plus 7 log B. Remember we did that at the end yesterday? So what we're doing is we're just going the opposite direction. So if I get rid of these exponents, like the coefficients, the exponents go away. So whenever I have an addition, it turns into a multiplication when I combine the logs together.
Thank you.
Mhm. Okay, so that addition right there, right, turned into this multiplication right there. So now I have log x squared minus 9x is equal to 1. Now the reason why I want to do that is to get rid of the base. It's just a lot easier in terms of math if we don't have a plus sign or subtraction sign in between. I'll show you why in a second. So over here, I'm going to base both sides. So once I have a single log, I'm going to base both sides. And what will happen is these two things will cancel. And now I'll get x squared minus 9x is equal to 10. So that's going to cross out. So now I have something that I'm familiar. Because that's a square, I'm going to make one side 0. And then I'm going to factor this puppy. Okay. So let me get everyone to catch up to here in terms of copying, because there's an important point I have to make. Now, on this last step, you have to make sure solution does not make the parameter negative. So go ahead, copy that, and I'll show you what that means. Okay. Now, we're going to do that over here. So we're going to look at x equal 10 first. You're going to plug into the original equation, always the original equation. So you're going to get log 10 plus log 10 minus 9 is equal to 1. And then you'll get log 10 plus log 1 is equal to 1. So go ahead, copy that, and then I'll tell you what that means. Okay, now. We're not double checking. I mean, you can double check to see if it works or not, but sometimes that's just a long problem. So we're actually not double checking here. What we want to see is the inside. Are the parameters positive? If both parameters are positive, that's a good answer. We're not checking when we enter it. We're checking it when we've actually simplified it. Okay, so when I've actually simplified it and I've gone down to this point here. So both parameters are positive. It's a good answer. If just one of them is negative, it's a bad answer. Okay, so go ahead and check x equal 1. Okay, plug it into the original equation. Okay, now over here, we'll go log -1 plus log -1 -9 log -1 plus log -10 is equal to 1. Now, both of these are negative, but if just one of these are negative, it's a bad answer. You cannot have a negative parameter. Now look, we're not checking here. We're checking after we simplify it. So it's possible for this to be negative, and then I put it into my log, and then after manipulating it, it remains positive. Then that's those problems do exist. So it's important that you actually plug it in and actually simplify. Otherwise, you might be crossing out something that actually works. Because it's possible for x to be negative. What you can't have is after I plug it back into here, that the resultant is negative. So over here, if any parameter, I'll say log parameter, is negative, It's a bad answer. We call it an extraneous solution, meaning that there's some error that developed as we work through our problem. So this is a bad answer, and this is the only correct answer. So you could have two answers, you could have one answer, you could have no answers. Just give everyone a chance to copy.
Professor,
Go ahead.
are there instances where the logs will have two different bases?
No, you never want to have logs with two different bases. If you do have the situation where the logs have different bases, what you want to do is use a change of base, that change of base formula I gave you, to make
Okay.
sure everything has the same base. So
Okay, thank you.
there never should be a time when you're working with two different bases. It's a good question. But once you have multiple bases, your life sucks. So we just always change everything to the same base. I say we as if I represent all mathematicians in this world. Okay, now. So we started this original problem from here, right? And then when we double checked it, one of them didn't work. Now what I want to do is I want to give you the same problem, but we're going to start our problem from here. So let's say I did give you that, what the original thing as, the original whatever, whatchamacallit. Let's just say I gave you this problem. Right, so I'm just taking it from here. Okay, so we didn't start from this, we're starting from here. Now go ahead and solve that problem. We should get the same thing. We should get x equals 10, x equals -1, but when we double check it, we should get a different result. So what's this? Okay, so go ahead and do base 10 on both sides. Now, base 10, base 10. Okay. That'll make this go away. Okay, now come on, finish this up. Right, bring the 10 to the other side and then factor both sides. Okay, -1. Now what I want you to do is I want you to plug it into this original equation. That's what it's really important you plug into the original equation. Okay. Oh, and then in your notes, could you also write the parameter also can't be 0. It has to be, so I think I said it can't be negative. It also can't be 0. The parameter has to be greater than 0. Greater than 0. It can't be negative. It also can't be 0. So let's look at this. I have log, I'm sorry, log 10 squared minus 9 times 10 is equal to 1. Log 100 minus 90 is equal to 1. Log 10 is equal to 1. And as long as this is positive, not negative, not 0, that's good. Now let's plug in negative 1. Log. And then we go log 1 plus 9 is equal to 1. So we see that this is also positive. It's not 0, it's not negative. It's a good answer. So we're good. That one works. Let's take a picture.
Professor?
Go ahead.
So when you plug in 10 and negative 1, you get log 10 equals 1 and log 10 equals 1. So
Yeah.
they're both positive, but they're also both the same. So the question that I think of is it possible that they're both positive, but they're different equations? Like, could
No,
one be log 12, or they have to
no,
be the
they
exact
have to be
same?
the same.
Okay.
Yeah. So if you get something like 10 and then you get 12 over here, you did something wrong with one of them. Okay, so let's give you one. Let's do another one just like we did. Let's start with the whole shebang. So let's give you something like this: ln x plus ln x minus 3 is equal to ln 4. Okay, so first combine these two. Let's take a look at it. So we're going to go ln x and then we're going to do the base to both sides. And then these will go away. So go ahead, factor it, solve it, and then go ahead and double check it. So we have x minus 4, x plus 1 is equal to 0. Okay. So if we look at x equal 4, we're looking at ln of 4 plus ln 4 minus 3 is equal to ln 4. So we get ln 4 plus ln 1 equals to ln 4. So these are all positive. Right? All the parameters are positive, so it's a good answer. Okay. Now go ahead and check it for x equal negative 1. So we should have ln of negative 1 plus ln negative 1 minus 3 is equal to ln of 4. Now, we already know that it's not going to work, but I'll just go one more step. So this is negative. We have a bad answer. Right? We have an extraneous solution. This one's no good. Let's try another one. Let's try something like log x minus log. I'll try. This is log x plus 2. Minus log x is equal to, let's call it 2. So while you copy that, you just copy the next problem. And I want you to see the difference between these two problems is that's a plus and that's a minus. Okay. Now, the way we start these problems are always the same. On this side, I had 2 logs. On this side, I have 2 logs. I want to have only 1 log. So the first thing we always do is we combine the logs. So I'm going to get log okay. Now, this plus, this means multiplication. So that goes right there. Over here, this means division. Let me actually make this green. Okay. So over here, if we have a plus, it turns into a multiplication. If we have a subtraction, it turns into a division. Okay. Now the way we get rid of that log is we're going to base both sides. Okay. So this is a 10. This is a 10. That'll cross out. And now I have x plus 2 over x is equal to 100. Now let me give everyone a second to just sort of breathe and copy. Yeah. The way you solve this problem is that this 100, think of it like a fraction. So what you want to do is cross multiplication. This times this is equal to that times that. So you're looking at 1 times x plus 2 is equal to 100x. We call that cross multiplication. So now you have x plus 2 is equal to 100x. 99x is equal to 2. X is equal to 99 divided by 2.
Professor,
Go ahead.
wouldn't it be 2 over 99?
Yeah, it's 2 over 99. Thank you. I'm dumb dyslexia again. The problem isn't when I do math, because then someone will go, hey, Dr. Kawhi, did you get that wrong? The problem is when I cook. Is when I put, instead of 21 of something, I put 12, or vice versa. That's what kills me in life. Okay. Now, let's make sure that it makes the parameter positive. So if I go log 2 over 99 plus 2 minus log 2 over 99 is equal to 2. That's 2 and 299. Both of those are positive. It's a good answer. Let's do both parameters. So these are the two main problems from here. So you'll definitely see one of these and one of these. And then I usually randomly pick one other one.
Professor,
Go ahead.
I have a question for clarification. On the previous problem, we have -1 and -4, which equaled a bad answer.
Yeah.
But on the one we did before that one, we had 2 negatives as well, and you said it was good, or did I mishear that?
No, so let's make sure we, all right, so let me just redo what we did previously. So I think in our previous problem, so we did two problems. We did this one. It looks something like this. x plus log x minus 9 is equal to 1. And this one only had one answer. X is equal to 10. That's the only answer we had. Because when we plugged in -1, it made this negative, it made that negative. That's why we crossed out -1. Okay. Now, so that situation is just like this situation. We had two answers, and one answer made the parameter negative, and we crossed it out. So that's why we have only one solution. So the very first problem we did was this one, and that's why we had only one solution. Now the next problem we did after that, to contrast it, I did log x squared minus 9x is equal to 1. Now when we plug in 10 in here, it's positive. But when I plug in x equal -1 into here, I got log -1 squared minus 9. So I got log 1 plus 9. So then I got log 10. So in the second problem, the solution for this one was both x equal 10 and x equal -1, because when I put -1 into here, that parameter was positive. Okay, so the very first problem was just like this problem. One of the parameters was positive, one of the parameters was negative. So I had only one answer. And then on the second one, because we started in a different place, when I plugged in both of these, they both ended up with positive numbers. That's why I had two solutions, not just one. Oh, I'm sorry about that, everyone. I don't know why, but my Zoom just died. Let's take a break until 8:15, and then we'll get started again. Someone had a question that I will answer. I'm glad everyone is still here. We'll get back to it in 8 minutes, right? So everyone just hang out for just take a short little break. Okay, let's get back to it. Sorry about that. Okay, so let me give everyone a chance to come back to their computer. I emailed everyone the solutions, not solutions, where your standing is. Um, a few people haven't taken the midterm yet. If you need an extension on the midterm, I don't automatically extend it for anyone who missed it. I need you to email me or I need you to call me, one or the other. And if you do, I probably will extend it. Okay. Now, the reason why I don't extend it automatically is because no teacher does that. Most teachers don't extend midterms. Um, I want you to get in the habit of advocating for yourself. Like going to the teacher and said, this is what happened. Can you help me out? Okay. Now, because this is a developmental math classes, a lot of times people don't know the process of how to get a time extension on their exam. So you normally what you want to do is you want to ask your teacher before. If you have a religious holiday, it is mandatory that we extend it as long as you give 2 weeks notice. Now, for me, I don't care. You can tell me afterwards. It was Armenian genocide. I went to the rally. I missed the exam. Can I come back? But this was important to me. And normally a teacher will say no. I'll always say yes. So in order to protect yourself, if something happens in terms of work, you get sick, your kid gets sick, most but not all teachers will work with you. You always want to email the teacher before the exam. It could be midnight, it could be 3 a.m. Say, I sent you a message, I had to go to work. I'm sorry, can we deal with it afterwards? So if you ask the teacher, if you send notification to teacher before, they're way more likely to work with you. If you tell them afterwards, oh, this thing, I went to work, I'm sorry, I missed it, they're less likely. Now, for me, I always extend it, but I'll only extend it if you ask. I got to get you in the habit of not being mousy. We know that students who are what's called help-seeking behavior, students who ask for help, they go to tutoring, they ask their neighbor, hey, how'd you do problem two? They go to the professor and say, I have this special circumstance, can you work with me? We know that those students usually make it, and we know that the students who are mousy, they're just quiet and go, I hope someone notices, I hope someone takes pity on me, I hope they work this out for me. They don't make it. They just get crushed, right? No one is going to go through the list like they did in high school and go, oh, I really care about you. Let me help you. This is public college. So if you missed the midterm and you need an extension, please email me or talk to me by tomorrow. By Sunday, what I want to do is open up a copy of the midterm so people can practice it for the final. So if you don't contact me by Saturday midnight, you're kind of out of luck, right? The midterms was 30%. I don't drop it. So someone had emailed me yesterday that they just had stuff going on and they missed it. I already extended that person until Saturday. So I'm already telling you, I'm going to help you out. You just have to contact me, okay? By Saturday. Okay, now that everyone is back. Oh, and one more thing. In terms of the final, the final is a hard deadline, Saturday noon. I'm going to try to release it for you to work on it probably after class on Monday. Okay, so if for some of the students here, this is all review and you're bored out of your minds, you can just be free of this class. You do your last exam, and then you have an extra week to goof around. For the rest of you, the majority of the people in this class, where this class has been kind of gruesome, you have until Saturday noon. There will be no practice final. The practice final will be all of the old exams and the old practice exams. Okay, is there any questions on that? Okay. So remember, most teachers will help you out if you email them before. Even if they don't respond back, email them your emergency right before you go to work or whatever it is that you have to deal with. Okay. Even if you call them on their work phone, when you see them again, you can just say, hey, you know what? I had this emergency. I left a message on your campus phone. So even that much is enough. Even if the teacher didn't see it, even if the teacher didn't hear it, it doesn't guarantee anything, but it helps. Okay. Now, someone had asked the question saying, hey, over here, this is negative and you crossed out the answer because of it. But previous, didn't we have a problem where the parameters were negative and you said it was okay? So let me sort of go through that explanation again. So the first problem I had was over here. So when we solved this, we got 10 and -1. But when I plug in -1 here, both parameters became negative. So I crossed out -1 as an answer. So this problem here had only one answer. Just like the problem we just worked on over here, this one had only one answer because this parameter became negative. After that, I contrasted it with this problem, where instead of starting from here, we started from here. So when I plug in -1 into here, this parameter is positive. That's why this problem has two answers. So even though this and this eventually churns into here, because we are plugging back into the original equation, this has only one answer, this has only two answers. And whenever this parameter is negative, we always throw it away. Okay, so let me give people a second. Did anyone have a question on that? Okay, so let's do one more like this, right? So when we have a negative, it turns into a division. Okay. Now, sometimes they'll give you the problem and it'll look like, they'll sort of hide that it looks like that. So let's look at something that looks like, I'll just make one up. Let's go ln. All right, try that problem. So remember that this thing, because this is a minus, this will turn into a division. Okay. Now do E and E on both sides. So we'll go E and E, and that crosses out, and get okay, now do cross multiplication, this times this and this times that. So we get 1 times x plus 3. Then we'll get 3x. We'll get 1 is equal to 3x. X is equal to 1 divided by 3, like that. So here we're going to check the parameter.
Professor,
Yep, go ahead.
shouldn't it be 4x plus 8 when you distribute the 4?
Ah, yes. Thank you. So 3x is equal to -5, huh? Okay. Now, this is a little bit better of an example because when you plug it into the parameter, what you want to do is turn it into a mixed number, because that'll make it easier for you to check whether this is positive or negative. So plug it into here. that. Now, if it's negative 5/3 over here, a lot of the times you're just not clear on, is that positive, it's negative. You don't actually need to calculate it. I know that 3 is bigger than 1 and change, so I know that that's positive. I'm not even going to bother figuring out what the value is. I just know it's positive, and that's all I care about. I know that 2 is bigger than this, so I know that this is positive. So I know I have a good answer. Okay, now let's do one last problem. Okay, 1 minus 2. Let's do sorry, 8. All right, so let's try doing that problem. So there's nothing to combine. All you have to do is just do base and base. The fact that it's 52 shouldn't freak you out because they're just going to cancel out. Eight minus 2x is equal to 1 minus x. Okay. Now check the parameter. See if it makes the parameter negative. So we have log 52, 8 minus 2 times 7 is equal to log 52, 1 minus 7. So log 52 minus 6 is equal to log 52 minus 6. Now, it does not matter that the left side and the right side are the same. You can't have a negative log, so this is a bad answer. So this is no solution. So I just wanted you to have an example. You just can't assume that if this is positive, oh, it works. And if this is negative, oh, it doesn't work. X can be positive, X can be negative. Once I plug it into my parameter and simplify, that's what determines whether it's a good answer or a bad answer. Okay, so what we're going to do now is we're going to go to section 10.1. And we got a healthy amount of time to finish 10.1. It's a formula section. It's just a whole bunch of formulas. And since you get to use open book, open notes, this should be easy points for you, right? Because there should be no mystery. I'm not making you memorize it like I usually do. Now, for those of you going to calculus, let me just tell you, memorize the formulas. You're going to have to memorize it when you take trig. You might as well memorize it now. Okay. Okay, so while you guys are copying, let me tell you guys a story. We're going to go over the Pythagorean Theorem. Now, the Pythagoreans didn't come up with the Pythagorean Theorem. They used the Pythagorean Theorem is that a squared plus b squared is equal to c squared. I'll explain it in a second. But that was discovered by, well, we know at least the Egyptians knew it. The Egyptians built the pyramids using the Pythagorean Theorem. So the question is, why did they get credit? A lot of reasons. Sometimes we don't give credit to people who are outside of our Western civilization tree, right? We go from the United States, we came from England, which came from Western Europe, which have Protestant roots, which then came from the Catholics, which are in Rome, then goes to Greece. And usually our heritage goes down there. And we really don't give credit to people who aren't in that tree. So we go, who discovered North America? Christopher Columbus. And it's not even a white-black thing. The Vikings discovered North America way before Columbus. And, you know, we don't count them. They're white. The Indians who are here, the native peoples, they discovered it. Sorry, we don't give you credit because you are not from the tree of Greek, Roman, Western Europe, Catholic, Protestant, United States. So one reason could be that the Pythagoreans were the first one in the Western civilization tree, which the Egyptians aren't in, to discover it. That could be it. The other reason could be is that they're the first. It's the very first theorem that was proved. So until then, the Egyptians, when they built the pyramids, they didn't prove it using math. They just go, seems to work a lot. We use it all the time. And the pyramid doesn't fall over, so it must be true. So there wasn't this feeling where we need to prove it. We use it, it works, we're good with it. Whereas the Pythagoreans was a religious cult. So they actually really looked at it intimately. They're the first people who proved that this is true, who came up with the idea of proving things. So they're the first ones to prove it. That could be why they're being given credit. Now, we don't know if Pythagoras actually came up with the proof because they're a cult. And like any other cult, I'm the leader, Pythagoras is the leader, and anyone else who comes up with something, guess what? I'm going to take credit for it. So the Pythagoreans came up with a lot of stuff. So if you look at your piano, what the lengths of the strings are, they came up with that idea of any kind of guitar or piano or any kind of string instrument. That model of the ratios of size of the strings is all from the Pythagoreans, like a harp. They came up with a bunch of things. The reason why is that the central idea behind the Pythagoreans is that they believe everything was a rational number, meaning that everything was a fraction. So if you had trouble with your husband and you wanted to have a conversation and say, could you give me some advice? And they'd say, well, the number for man is 1. The number for a woman is 2. Sorry, they're a little misogynistic back then. The number for marriage is 12. And then as you told them their problems, they would write down the numbers and they would do some math and you go, well, your answer is 37. I guess you got to leave them. So they were numerologists. They were also vegetarians who believed in reincarnation. And they were also murderers. So we've learned in this class that square root of 2 cannot be written as a fraction. It's something like, 1.21, it goes on forever. Now, this was discovered by a Pythagorean. His name was Hipparchus. So Hipparchus discovered, right, a proof, because this is the first group of people who are doing mathematical proofs. Not only that, they're there because they love the math. They can all understand the proof. So he went and said, hey, you guys, I proved that square root of 2. It's impossible to write that as a fraction. I proved it. Look. So what they did was they treated him like Fredo. If you guys ever watch The Godfather, you know what you do? You tell Hipparchus, hey, you want to go fishing? They go, yeah, I love fishing. Great, we're your friends. Bring your proof with you. And he took him up. They took him up to the lake, killed him, and drowned him. So basically, this is the first Fredo. Now, the Pythagoreans have a lot of influence over your life, whether you know it or not. Okay. The Pythagoreans were the very first, well, let me not say very first, but the Pythagoreans believed in learning and in learning math. Now, they were actually very progressive in the sense that they had no problem with women learning. So they would, meet in Athens and they would study. And then women were also allowed to join them and study with them. So they were very progressive in that way. Now, they're a cult. So Pythagoras is up here, you're down here, and I get credit for everything you do. Now, years later, after Socrates was forced to commit murder, his disciple, Plato, who was a rich guy, was sort of distressed, right? So Socrates was the original hippie. He's this guy, he's kind of homeless, and he's just sort of arguing with people, saying, you know what, don't trust the government, like question everything. So he was the original hippie, and he had a following, and Plato was sort of a rich little disciple of his. Socrates never wrote anything because, again, he's a hippie. Everything we know about Socrates is what Plato wrote. Plato said Socrates said this, and Socrates said this. He wrote these long books that talked about what Socrates said. So it could be BS. We don't know because the only words we have from Socrates are through Plato. Now, Plato is a rich guy. So what does a rich hippie do? A rich hippie goes, what we need to do is spread this hippiness, and what we need to do is create a place of learning. So we call it the university. So the very first university is called university. That's why we call this a university. So Plato needed a model for school because there really wasn't one. And what he copied was the Pythagoreans, right? A murderous cult. So that's why when you see school, it's why it's set up this way. So look, I'm here. You don't get to question me. I'm right. You're wrong. If I'm going to do this and you're going to copy it, and you're going to assume that whatever I tell you is correct. You know why? Because I'm up here and you're not. Now, where did this come from? The original university. How was it brought to us? Through the Catholic Church. So what happened was, this is hundreds of years before Christianity. But a lot of Christianity adopted a lot of things that the Greeks did, because the Greeks was this place of great learning. So when you got an education, you learned what was called the classics. That is Roman and Greek theory. Okay. So when Catholicism started to become a major religion, because before they were a small religion, they were sort of an outcast little group, but then they started becoming large. And at that point, they said, what we need to do is we need to create schools that train pastors if we're going to grow. And that's why the seminaries for the Catholic Church and also the Christian Church really worked off of the original Plato University model, which was originally created by the Pythagoreans. So all this education, how the Catholic and Protestant hierarchy and the religion, how that training is set up, is directly connected through the Pythagoreans, right? And which is why, again, your priest stands at the podium, and then it's not like you're having this interaction with the pews. Now, this is so inundated about how we think about learning. Just know that there are other models of learning. Let's look at the Mormon Church. Okay, Mormons do not have seminary. They have lay leadership, meaning that each man who's given the priesthood, so reaches a certain commitment in the Mormon Church, they take turns giving lecture. So imagine if we redesigned school, where I said, today, Simon is going to do lecture. And then Arthur, you better pay attention because you're doing section 11.2 tomorrow, right? And then Mitzi, you're doing section 11.4 the day after. So each of you have to pay attention. Why? Because in about sometime this week, you're going to stand in front of everyone and you're going to explain the next section. So you've got to be good enough to read the next section, figure it out, and explain it to everyone. So that's a different model of learning. There is no leader. There is no, I say this, and then I pass it down to someone else, and then they pass it down to someone else, and then we have this lore. There is this, each one of you is responsible for a different day, so you better pay attention. Otherwise, there's just this public embarrassment. Okay? So this is not the only way to learn. It's just the way that we've chosen to learn, because it's been passed down from the Pythagoreans, through the Catholics, through the original university, to where we are now. So this is why we learn this way, but it's not the only way to learn. Okay, So enough of that history lesson. But just so you know, those Pythagoreans were scary people. Okay. So every time I go to like the Getty, and you'll see some bust of Pythagoras, I just go like, oh, that guy's like the guy who's in charge of the Branch Davidians, because it's a cult leader. Doesn't mind killing people to have his cult move forward. Okay. Now, and then let me just say, so I don't get in trouble, I'm not saying that Christianity is a cult. I'm not saying the Catholics are the cult. I'm saying the model of learning that they follow originated from what was a cult. Okay. Now, let's get going. Let's go to section 10.1. Okay. So we have, let's see. So we have lots of formulas. Okay, so we're going to have distance, midpoint, and Pythagorean theorem. Okay. Now, the Pythagorean theorem has to do with the length of the sides of a right triangle. Okay. If you have a right triangle, meaning that one of the angles is 90 degrees. So let's say you have two A, B, and C. Okay. So a right angle is 90 degrees. Now, this is one of the ways we look for aliens. 90 degrees doesn't happen in nature. If you go to the forest, you don't see trees that look like this. Right? You don't see rocks that look like this. If you pop out a microscope, you still don't see 90 degrees. You only see 90 degrees when you see evidence of civilization. So there are always people in telescopes going, I see a right angle on Mars, aliens. But it is one way we look for aliens. Okay. So this is the right angle over here. Now, the sides that are connected to the right angle are called legs. They're connected to the right angle. Over here, this is the hypotenuse. Now, A, B, and C are all lengths. Okay, so understand what A, B, and C are. It's the length of this, the length of this, and the length of this. So let's say I give you a question where I go, hey, this is 3 inches. This is 4 inches. How long will that be? Okay. I want to know how many inches that is, what that length is. Now, what you'll do is you'll label the legs A and B. Now, it doesn't matter whether that's B or if that's B or that's A or that's A. the legs can be either A or B. And just name one of them A, name one of them B. But the hypotenuse has to be C. That one is mandatory. Okay. So what we're going to do is we're going to use the Pythagorean theorem. Okay. So you have A squared plus B squared is equal to C squared. So then I'm just going to plug in those values. And now what we're doing is we're just doing the algebra that we learned before. So let's use order operations to solve this. So we do exponents before addition. Okay. Now, because this is a distance, right? If I ask you how tall you are, and you go, oh, I'm 5'8", you don't say negative 5'8". If I ask you how much do you weigh, and you said 150 pounds, you don't say a negative 150 pounds because you're not weird. Whenever we give a distance, we only look at positive numbers. So even though I'm square rooting both sides, you don't have to worry about negative numbers. Okay, so I'm not putting plus or minus there. If you tell me, oh, how long is that line? I go -5. I'm probably going to fire you from the construction site because what a weird way of saying that. You're definitely not going to get away with that in a job interview. Okay, so remember that x is a length. That's why it's always positive. Okay. So let me give you another one. Let me do it this way. Okay, so this is x. Here's my right angle. We're going to make this 3, and then actually I'm going to make this 2. 2, and then I'm going to make this 6. So go ahead and find x. Make x the c, right? Because it's the hypotenuse. So we have a squared plus b squared is equal to c squared. I know that no matter what, my hypotenuse has to be c, and these other ones, it could be a or b interchangeably. So if you made this one a and you made that one b, no big deal, it still works. So we get 6 squared plus 2 squared is equal to x squared. So 36 plus 4 is equal to x squared. 40 is equal to x squared. Now, in order to get rid of that 40, I'm going to square root both sides. Now, the book says just use a calculator and round it to 1 decimal place. Normally what happens is, so at that point, you can just use a calculator here. But no, in most books, what they do is they make you simplify the rational number. So if you're going to use a calculator, just use it from here. Just stop. But be able to do this depending on how the question wants you to answer it. Okay. Now, all right, let's go over here. Now, there's 2 ways for me to ask you this question. So one way is this way, and the other way is this way. So in both of these questions, my x is the hypotenuse. I can also ask it to you where x is one of the legs. Let's make this 3, and let's make this 7. Okay. So the difference between this and this is that my hypotenuse is an actual constant, but we'll make this one a so everyone's work looks the same. But I made one of the legs a variable. So go ahead and plug it into here and see what you get. And this is a cornerstone formula. All of math starts with this formula. If this was wrong, all the buildings would fall, the satellites would tumble, the moon would crash into the earth. Almost everything we built is based on this being true. So remember, A is now x, B is 3. Okay, so the difference between this and this is that because my variable is a leg, it'll be on this side. When it's a hypotenuse, it'll be on the right side all by itself. Okay, so work that through. X squared plus 9 is equal to 49. So x squared is equal to 40. So x squared is equal to 40. And then I'm going to square root this, square root that, and I get x is equal to square root of 4, square root of 10. Okay. Now, weirdly, we got the same answer. I didn't mean for that to happen. It just randomly happened. Go ahead, copy this, and then I'm going to show you how to round it. So over here, if it says round decimal to 10th. Okay, so I'm going to, this is how most books do it, but I'm going to show you how to round that to the nearest 10th. Okay, so go ahead and copy that first, and then if you have trouble rounding, we can talk about it. Okay. So over here, we get 6.34, 324, 555. Now, the 10th is over here. That's the 10th. That's the 100th. So if this number is bigger than 5, it's 6.4, or 5 or bigger. If this number is smaller than 5, then we keep it the same. So over here, what we're going to do is we're going to keep it the same. Okay. So in your XYZ homework, they want you to have that. Okay, let's take a 10-minute break, come back at 10:20, and then we'll knock out the rest of these formulas. Okay, so come back at 10:20. We're in a good place. We don't have to rush. Okay, let's get going. So let's finish up the last little bits of this section. Well, it's not last little bits. It'll take the full hour. We've got two small things and one semi-big thing to cover. Okay. So let's start with the basic formulas. And then each one of these formulas, you'll get a Pythagorean theorem, you'll get a midpoint and a distance question. And then circles are also in this section. Okay. Now, where am I? Here we go. So let's look at the midpoint formula. Okay, so the midpoint between x1, y1, and x2, y2 is x1 plus y1 over 2, I'm sorry. y1 plus y2 over 2. Okay. So copy that, and then I'll just sort of explain what that means, right? Because right now that should look like a bunch of gibberish. Okay. So let's just sort of talk about this. Let's say that I have 2 points, right? Let's say I have 2, 1, and then I have 6, let's say 11. Let's just say. Okay. Now I want to find the midpoint. The midpoint's right here. Now, what you want to do to find the midpoint is find the average value of the x values. See, this is 2, this is 6. The average value will give you the middle of these two numbers, right? 2 plus 6 divided by 2 is equal to 8 divided by 2 is equal to 4. So boom. 4 is the middle between the two x values. And if I wanted to find the middle over here, in terms of the y values, well, this is 11 and this is 1. Then the average of these two values is 11 plus 1 divided by 2, which is 12 divided by 2 is equal to 6. So that would give me this right here. So the midpoint would end up being 6, 4. I'm sorry, 4, 6, right? So that midpoint there would end up being 4, 6. So all you're doing is taking the average of the x values, the average of the y values, right? Add them up, divide them by 2. So the middle point of this and the middle point of that, and that gives me that. Okay. So on your exam, you don't have to copy that. You just need to know to use this. Just say find midpoint between -1, 9 and 10, 2. I'll make it a negative 2. All right. So go ahead and do that. Add the x values, divide by 2. Add the y values, divide by 2. Let me give everyone a second to copy whatever they want to copy and work on that. So let's go. We have -1 plus 10, and then over 2, and then we have 9 plus -2. So this turns into 9 over 2, 7 over 2. Done. Okay, so you don't have to draw it. You can just compute it by taking the average of the x and the y. Now the distance formula, if I had more time, I would go and tell you how it's created. It's not very hard, but it's based off the Pythagorean Theorem. But I don't want to run out of time when we work on circles. So we're just going to say, you know what? It works. If you want to know why, Google it. Okay. So we go distance between x1, y1, and x2, y2 is equal to square root of x1, it doesn't matter, x2 minus x1 squared plus y2 minus y1 squared. So this looks just like the slope. It doesn't matter which one is x2 and which one is x1, right? So either point that I give you could be x1 or x2. Well, let me just give it to you, and then I'll explain it. We'll do that. Okay. Now, what I was mumbling about was that this one could be x1, y1, or this one could be x1, y1. It doesn't matter. It's not the first one is x1. It's either of these can be x1, y1, x2, y2, or x1, y1, x2, y2. It doesn't matter. Just like slope, it doesn't matter which one comes first. So go ahead and plug and chug it into that formula. And this thing gets used everywhere. So if you're taking trig, be sure to memorize this one because you'll be using it over and over and over. Even if you don't memorize it, you'll use it so often that it'll just be automatic. So let's take a look at this. So put the x's together, put the y's together. So you end up getting -6 squared plus -5 squared. Now these will become positive. The inside of this will always be positive. And then done. Okay. And it looks like we're going to have extra time. Now I don't want to bury you with work right before your quiz. So I'm going to cap the exam at 10.1, but we're probably going to start 10.2 just to make life easier for us on Monday. Okay. Okay, so this is done. Let me give everyone a chance to copy, and then we'll move on to circles. Now, while you guys are copying this, There's probably a decent question of why the hell do I need to know circles? For anyone here who's going to become an engineer, some of you computer science.
Professor,
Go
I
ahead.
have a question. Where'd you get the 21 from? Wasn't it
Oh,
25?
25, yeah. Okay. Weird, right? I think I said 25. I even added 25. But unfortunately, my brain sees 21. All right. All right. And the question is, why the heck would I need to care about circles? The people who care about circles is anyone who works with geometry. So for example, if you're working for NASA, if you're working for automobiles, you're going to calculate very difficult shapes. So let's say I have this asteroid and it's spinning, and then it's going to hit the ground, and then it's going to hit in a mirror image, depending on what part of that asteroid hits that ground. Now, the first thing you want to do is test, well, maybe it doesn't hit the ground. Maybe I have something like looks like this. I don't want to spend a lot of time trying to compute whether this very difficult shape hits the ground until it actually hits the ground. So what you'll do oftentimes is you will pretend that this is a circle. You'll put a circle around this, and until this circle actually hits something, I won't do the micro calculation. Now, no matter how weirdly shaped an item is, at some micro level, it'll hit. And at that point, we will estimate the side of a circle or a point to determine when this bounces off, does it look like a spin a different way, or does it go this way? At some point, we'll use either a point, either bounce it off like a point, but if we want to have rotation, we will estimate that whatever this contact is with a circle. So just like all curves that you see on your computer, eventually, at some point, at some micro level, we're estimating contact with a line. So all curves at some micro level in a computer is at some point a line. Same thing here in terms of large shapes. At some point when they contact each other and we figure out what's happening, at some micro level, we're doing some calculation with a circle. So for anyone who works with anything geometric, so for me, I used to work on computer animation. So I'm throwing asteroids at spaceships, and I'm shooting things, and I'm spinning things. I'm always using a circle for my first prototype. Make sure that works, and then I use this shape, and at some point, my contact is going to be a circle. So if you go, why am I studying circles? Because they're everywhere. They're the easiest 3D shape to work with. They're much easier to work than squares. Okay. So for those of you who do any kind of geometry in your living, at some point, a circle is going to be a big part of your life. So let's look at the formula for circles. I'm going to erase this. So we have x squared plus y squared. Oh, sorry. Let me give you the full one. X minus h squared plus y minus k squared is equal to r squared. So when I have a circle, I have two parts to it. I have the center, which is h comma k. That's my center. And then I have my radius, which is r. Okay. And the radius is the distance from the center to the outside of the circle. Okay. So let's do an easy one. Find the equation of a circle with center 2, 3, and radius equal to 4. So all you want to do is plug this into here. Okay, so this is your H, this is your K, and this is your R. So go for it. Okay, so we have x minus something squared plus y minus something squared is equal to something squared. And all we're going to do is we're going to fill in the blanks. It's nice, they're all in the same order. 2, -3, and 4. And I get x minus 2 squared plus y plus 3 squared is equal to 16. And I'm done. That's it, done. And if you go, would you put that on the test? Oh yeah, it's going to be on the test. Okay, so don't blow that question. Have the formula on a piece of paper next to you because I'm going to ask you that question. Okay, let's do another one. Find the equation.
Wait, Professor.
Yeah.
For the circle formula, is that our answer at the bottom? Is that it?
Yep, that right there.
Okay.
And the nice thing of, see, you don't want to foil this. If you foil it, you lose all the information. If you hand this to someone, they go, oh, radius is 4 and 2 minus 3, that's my center. So usually with circle, you never ever foil it. You just leave it like that. Of a circle with center 5, 0 and radius equal to let's say 7. Okay, so go ahead and do that. Okay. So then this is going to turn into x minus something plus y minus something. And you're going to get 5, 0, 7. So then this just turns into x minus 5 squared plus y squared equal to 49. Now, I want you to see something, that if we don't see a h or a k, it just means that that center has a 0 for that coordinate. Okay, so I want you to see that right there. Okay. So go ahead, copy that, and I'm going to write the next question. Shoot. So go ahead, copy that, and then we'll work on this next question again. Okay, so let's sort of look at this. Now, we can sort of see that when we have a 0 for k, then we end up with a y squared. So what we want to do is do the same thing here. We want to say, well, when I don't see an h, I can just add it. Okay. Now, if we look at the formula, I'm sorry, there's a square here. If we look at the formula, it looks like x minus h squared plus y minus k squared is equal to 4. So we could see that, I'm sorry, it's equal to r squared. Okay. So if we do pattern matching, we could see that this minus h is equal to 0. Oh, square should be on the outside. Yikes. and that this minus k should be equal to 7, and this r squared is equal to 4. Okay, so if you're copying, just look up. I'm going to give you a second to copy. Okay, so we see that if we do pattern matching, everything else is identical. The only thing that's not identical is this minus h is 0, this minus k is 7, and this r squared is 4. So this gives us 3 problems to solve. And then now you just solve for h by dividing both of these by -1, divide both of these by -1, and then square rooting the r squared and the 4. Okay, so go ahead, do that. So then I have h is equal to 0, k is equal to -7, and if I square root both sides, now remember, we're not doing plus or minus because radius is a distance, right? It is how far am I from the center to the edge. Since that's a distance, we only care about the positive value. So my center is 0, comma -7, and then that's my radius. Okay. Now we're going to spend a little time here. I'm going to make it a little bit harder, which is going to be okay. It's not going to be that bad. So let's do this one more time to make sure that we have this in our pocket. Okay. All right, let's try that one. So remember that this right here is equal to minus h. This right here is equal to minus k. And this right here is equal to r squared. Okay. So you have minus h is equal to 2, minus k is equal to minus 5, and r squared is equal to 8. So you have h is equal to negative 2, k is equal to 5, and then r squared is equal to 8, and let's square root both sides. So my center is negative 2 comma 5, right? It's the opposite of what sign is there. And then my radius is equal to square root of 4 square root of 2. Okay. So if I'm having a good day later today and my wife makes me bacon on Saturday morning, that would be the question I give you. But, my daughter is on social media all day because we are all home because of the pandemic. So every so often when I'm teaching, she gets a little text from this boy. She's 12. He's 12. So if I'm writing your exam, in the middle of the exam, I get a little hiya text from a 12-year-old boy trying to flirt with my daughter, then we're going to give you a completing the squares problem. Okay. So this one right here. Find center and radius of x squared plus 6x minus 2 plus y squared is equal to 10. Actually, let's make it smaller because I'm going to have to add some stuff to it. Let's make it 3. Okay. Now this sucks because this is not in this pretty form. See, I have a nice little square here and I have a nice little square there. So what I'm going to have to do is I'm going to have to complete the square. Okay. Now let's remember what the complete the square formula is. Right, so complete the square. So the complete the square formula is, x squared plus b over 2x, plus bx, plus b over 2 squared is equal to x plus b over 2 squared. Okay, so we're going to use this. Okay. Now, we're going to do the same thing we did when we completed the square before. Now, the nice thing is that in these problems, we don't have to get rid of a. That includes this one and this one. This x squared and that y squared will be 1. So we're okay there. But the only thing we have to do is get rid of the constant on the left side. Oh, sorry, let me write it up here. So what I'm going to do is I'm going to add 2 to both sides. Now, I don't have to worry about completing the square here because I don't have something with a y. This is fine. This will turn into y plus 0 squared. So in terms of what I have over here, I'm happy, right? I can make it look like, oh, shoot. This was supposed to be a y. I can make it look like this. The problem is I need to make this look like that. And I know I need to complete the square here is because I have an x. So what I'm going to do is I'm going to add the b divided by 2 squared to both sides. Okay. So over here, I'm going to add b divided by 2 squared to both sides. Okay, let me give everyone a chance to copy. So whatever this is, right, divided by 2 and square it, add it to both sides. So now I get x plus 3 squared plus y plus 0 squared is, let me move it down a little bit. X plus whatever is in here goes here. Right? So it's a positive 3. I'm going to put that there. Now I want you to tell me, what is h equal to? What is k equal to? And what is r equal to? So now we have minus h is equal to 3, minus k is equal to 0, r squared is equal to 5. So h is equal to minus 3, k is equal to 0, and then in terms of r squared, we can get rid of the square by square rooting both sides. then r is equal to square root of 5. Okay. Now the next question you're probably asking yourself is, do I really have to learn to do this? Is this really on the test? And the answer is, yeah, it's going to be on the test. Okay, either something like this or something like my next example. Okay, and then I think by Monday we'll have covered everything except for one section. Now, usually that section, when we go over it in pre-calculus, they'll do the same section in pre-calculus, so I'm not stressed out about it. But for those of you who want to go pre-calculus to say, hey, you know that section you missed, I'd actually like to look at it. I'll tell you what section it is on Monday. I actually have a video of the actual lecture, which is why I saved it, because if you're in pre-calc, they usually review it. But if you want to get a leg up in pre-calculus, if you watch the video, it'll give you the entire lecture. Okay, so we're probably going to cover everything except for one section.
Professor?
Yep.
I have a question on the last example. Where did the b square on the right side go?
Oh, this one here? Okay.
No, on the right side. With 5 plus b.
It should be here. I'm sorry. It should be 9. Yeah, so this should actually be 14. I'm sorry. I missed it. So thank you. Okay, thanks for catching that for me. So yeah, I should have taken it into account and I didn't. Let me delete that. Take this picture. Okay. Okay, so on Monday, we will have covered everything except for one section. And then I'll be sure to, on Monday, because I don't want to distract anyone before the quiz, I'll email you the video so that, for those of you who are concerned about it, you'll be covered. Okay, but it will not be on the test. Okay, it's just for those of you who are taking calculus, business calculus or calculus. If you wanted just a leg up because they'll cover that section, go ahead and look at it after all of this finishes. Okay. Now, what I'm going to do is there's two types of problems. One where you have just a 6x, and another where you have both a 6x and then maybe something over here that has a y, something y. So let's do that one. Okay. So we have x squared minus 4x plus y squared plus, let's call it 10x is equal to 0. So I already removed all the constants. I just want to show you that because I have an x here and I have a y there, I have to complete the square for both of those separately. So I have to complete the square. And then I have to complete the square. Okay, so let me let everyone catch up copy. So I'll do one of these and then I'll let you do one of them on your own. So we get x squared minus 4x, and I go plus y squared plus 10x. And then we delete this. Plus 10 divided by 2 squared is equal to negative 4 divided by 2 squared plus 10 divided by 2 squared. Okay, so we're going to add the b divided by 2. So this is negative, that's why the inside of that's negative. This is positive, which is why that's positive. So we're going to add that to both sides. Okay. Now the reason why I'm doing this is this move is going to be done in the calculus for scientists. So just knowing that this move is available to you, I just want you to have that because a few semesters down the line, you'll see it. Okay. So now this will turn into okay. So anything that's in here will go here. Anything that's in here will go there. Like that. Now, the reason why it's important to the reason why it's important that I keep the negative is that right here this will be negative. Over here it doesn't matter because when I square it, I'm always going to lose that negative. But the reason why you want to make sure that that's a negative is because when I make this transition over here, this needs to be negative. So figure out what negative h is equal to, figure out what negative k is equal to, and figure out what r squared is equal to. And then solve for the center and the radius. Okay. That right here is your negative 2. That right here is your 5. Okay. So now we have h is equal to 2, k is equal to -5, and then we'll square root both of these. So then your center is 2 comma -5. Okay. Now let's take a picture of this. Okay, let's do one more. I want you to do one on your own. Okay, so I'm going to leave this up here. Okay. Oh, I'm sorry. Oh, I'm sorry. This should be y. Okay. Let's go 3. Okay. Let me make sure. I might have screwed up the. Yeah, let me retake a picture of this. All right, forget this for a second because I screwed up the last one. Let me make sure that I wrote this wrong. X squared minus 4x plus y plus 10y is equal to 0. Let me take the right picture. I think I put 10x by mistake. Okay, so that's now correct. Okay. So in your notes, this should be a y and that should be a y. Okay. Now, let me give you the other problem that we're going to work on. The x squared plus 12x plus y squared plus minus 2y is equal to 3. I think that's what I gave you. Yeah. So go ahead and do the same thing. So the thing I screwed up is that these two are y's and these two are x's. Okay. So complete the square of the x's and y's separately. One second. So let's add the b divided by 2 to both sides. So I'm going to add the 12 divided by 2 squared. Then over here, I'm going to add the minus 2 divided by 2 squared. And then over here, I need to add the 12 divided by 2 squared. Like that. And this is the minus. Okay. So go ahead and okay, so this part's the same. So remember, this inside goes here, this inside goes here, sign and all, and then you got to square all that stuff there. So this will come in here. This will come in here. And over here we'll get 6 squared plus -1 squared. So then I'll get x plus 6 squared plus x minus 1 squared is equal to 3 plus 36 plus 1. Then I'll get x plus 6 squared plus x minus 1 squared is equal to 40. And then you'll have minus h is equal to, minus k is equal to, and then r squared is equal to. Okay, so work your way down with that. So then you'll go 6 minus 1, 40. So h will be equal to 6, k will be equal to 1, r squared. I'm going to square root both sides. So my center, let's think, will be -6 comma 1. And then r will be square root of 4 square root of 10. That. Okay, so we're done. It's 11:29. I'll hang out to answer questions. Your quiz 3 will be up to section 11.1. And then we're actually going to cover 4 sections on Monday, but 2 of them are extremely short. And then the last 2 are usually put in the same section. In this book, they happen to split it into 2. So even though there are 4 sections, they're 4 fairly shortest sections. And then we'll be done. And then the one section that we didn't cover, I'll give you the video for you to follow up on your own if you want. Okay. And other than that, sometime later, either tonight or tomorrow morning, I'll have the practice quiz up. And then quiz 3, it'll be available to you Sunday at noon. and then you have to turn it in by Tuesday midnight, just like always. Okay, and then hopefully Monday after class, the final will be available for you. Okay, and then we cannot push the final beyond Saturday noon. Okay, everyone, I got to get everyone a grade. So if there's something special that happens to you, give me a call, right? Don't email me. So there are a couple things that I can do. There's what's called an incomplete, but what an incomplete is if you are passing the class and something extraordinary happens. Someone gets sick, you get in a car accident, something extraordinary happens where you can't take the final. You then have 1 year to take the final, but you get no instruction. So you can't come back to me and goes, hey, teach me 11.4. Like, no, class is done. Class is over. You have 1 year to take the test, and if you don't take it, it's an automatic F. Also, you don't get credit for the class. So if you're trying to fulfill a prerequisite for it, it doesn't work. Also, you can't re-enroll in this class because technically you're in limbo. So if you're someone where, let's say, you get COVID and you need 2 weeks to get over COVID and then take the test, absolutely. But if you're like, hey, I'm flunking this class and I need more time, absolutely not. It's not made for someone who's like, if you're flunking the class, you're ineligible. You have to be passing the class to get it incomplete. So if you're just not ready, just take the not passing grade and move on with your life, re-enroll in the class, and that's fine. But only under extraordinary circumstances will I give someone an incomplete, because it usually screws them long term if they're not ready to pass that final. Okay? Okay, thanks everyone. And then if you have questions, talk to me.
Professor?
Yeah, go ahead.
Just to make sure, if we don't want to take the last quiz, we don't need to, right?
You don't need to.
Okay.
But again, I would just do what you don't know. So at least it tells you what you don't know. So then when you're studying for the final, you at least know those ones I screwed up, do those. I would rather you get an F on it than not take it, because I want you to know what you don't know.
Okay. Thank you, Professor.
Yeah, but yeah, it's dropped the score.
Professor,
Uh-huh.
just a clarification. There is 11.2 to 2.5 will not be on the quiz, right?
Which one?
11.2 to 11.5.
No, that's on the quiz. Everything we covered this week is.
Okay, thank you.
Professor?
Yeah, go ahead.
Are we gonna have homework after the final?
No. So the only
you.
homework, the only thing is study.
Okay, thank you.
Yep, no problem.
Professor?
Uh-huh.
So if we'd like to do quiz 3, it won't count towards our grade, correct?
If yeah, you drop the lowest score.
Okay, yeah.
So I'd rather you take it and flunk it and know what you don't know than skip it.
Yeah.
Okay.
Thank you.
Any other questions? And then Donaldo, do me a favor, give me a call. I emailed your student email. Please give me a call. Okay, so you're not confused in terms of your status. Okay, thanks everyone. Hang in there.